equation we're working with impulse and change momentum. We know that impulse is force times time. You can probably put change in time here. And change momentum is mass times change velocity, as long as the mass is constant. So what we have when we have a person up this high from the ground, they fall, and right before they hit the ground, they're going to have some initial velocity. They hit the ground. When they hit the ground, there has to be a force applied up on them, and that force is applied for some time. This applied force and the time is the impulse that's applied to that person. The final velocity is going to be 0. This has some maximum velocity right before they hit the floor. If they land bent-legged, then what that means is this time is going to be large. So this mass and this velocity, or change velocity, is right when this person hits the floor. Now, when we landed bent-legged, this time was large, which means this force could be small. So a small force times a large time equals this mass times change in velocity. Now, if we go the other way, if we land stiff-legged, then what happens? We still have the same initial velocity. The final velocity is still 0. But then, which means this mass times change of velocity is constant. This didn't change between the two jumps. This stayed the same. So this number had to stay the same. But when we landed when we landed stiff-legged, this time became very small. Very small. So if this number is going to have to stay the same, then this force, that force has to be applied to it, has to be larger. And so when we landed stiff-legged, the time became small. That force had to be larger in order for the same change in momentum to occur. And that's the difference. The impulse is the same, but the force and time is what changes in that equation.